Good evening, class. Today's focus will be arc measures. Last section was all about tangents, their lengths, how to set them equal, how they were perpendicular to radii. But arc measures, we're going to be looking at a different part of the circle. In fact, we're going to be looking at the circle itself, but only a part of it. And that's why it's an arc measure, and it's an arc, because it's only part of the circle. So, arcs and notation. An arc of a circle is part of the circle. It's not the full circle. A minor arc accounts for less than half the circle, a major arc accounts for more than half, and a semicircle accounts for exactly half of the circle. So, before we actually look at notation, let's clarify what an arc actually is. If I would draw a circle here, and I did a pretty good freehand drawing, yes, I'm going to put a center here. We're going to call it P, because I wanted to. I'm going to put 3 points out here, A, B, and C. Now, if I would look at a certain, not at length, but if I look at a certain part of the arc, if I look from A to B here, that's only that part of the circle. That's a minor arc because it's less than half the circle. If I just looked at this part of it, that's definitely not even half the circle. It's a minor arc. Let's look at a semicircle next. A semicircle accounts for exactly half the circle. So the minor arc was in red there, and it was from, for instance, A to B, because it's only a small part of the circle. Well, the next one we're going to look at is what we call the semicircle. The semicircle accounts for exactly half. So, for instance, from A to C here, that would be a semicircle. Because even though I didn't draw it perfectly, that's supposed to be a diameter. So this was supposed to be exactly half the circle. So a semicircle is half of the arc, or sorry, half of the full circle. So I'm talking about the actual edge of a circle when I'm talking about the arc. And now a major arc is the part of the circle that accounts for more than half of it. So for instance, if I went from A through C here to B, and I was talking about this right here, this would be a major arc because it's accounting for way more than half the circle. So that's a major arc. Now, there's different ways to notate it. For instance, if I'm looking at minor arc AB here, well, for minor arc AB, I'm just going to label it this way. AB, I'm going to put an arc symbol over it. Good. Minor arc AB, that's the way I'd read it. Now, if I look at the semicircle, well, the semicircle is A to C, but it goes through point B. In this case, I'm actually going to add that third letter. This is semicircle ABC. And this blue arc here, well, it goes from A, it goes to B, but it goes through C. So this is major arc ACB. For major arcs and semicircles, you need 3 points to label it. The end points go on the outside, the point it goes through goes in the middle. The end points go on the outside, the point it goes through in the middle. So for instance, it goes from A to B, but it went through point C, so that's why point C is in the middle. It went from A to C, but it went through point B, that's why point B is in the middle. You have to label both a major arc and a semicircle with 3 points. A minor arc, I expect, and I will only see 2. Okay? A minor arc uses only 2 points, the end points, and you put an arc over the top of it. And there we go. That's the notation for arcs. Now, the measure of an arc is a little bit different. The central angle is the angle formed by the endpoints of the arc and the center of the circle. So in that picture that you see, this has a straight segment running straight through P. And it has a segment here. And then they say, all right, for this right here, we have this being 80 degrees, this is 100 degrees, and I didn't label anything else. However, if it cuts the circle in half, which a semicircle does, it measures 180 degrees. So over here, that central angle is going to be 180 degrees. Now the central angle I'm talking about, if you look for minor arc AB here, the red one, the measure of it will be the measure of the central angle, so the angle formed with the center of the circle and the endpoints of my arc. So the measure of arc AB here is straightforward, 80. Measure of arc AB equals 80 degrees, because that's the measure of the central angle. Now, if I ask the question, what's the measure of arc ABC? Well, ABC is a semicircle. So it's not just 80, it's not just 100, it's 180 degrees. So the measure of arc ABC equals 180 degrees, because the central angle is 180 degrees. And last but not least is the major arc. The measure of arc ACB will equal, well, 180 plus 100. So 180 plus 100, that's 280 degrees. Now, I know we haven't dealt a whole lot with angles that are larger than 180. But in this case, the central angle is larger than 180. It's in fact 280, because from here to here is 280. If I went the short route, it's only 80. But if I go the long route, it's 280. And there we go. That's how you find the measure. Is you just look at the central angle, the angle formed with the center here. If there's more than one, you can add them together. So let's do a little bit of an example here. For each arc, determine its measure and determine what type of arc it is. Segment AB and segment CD are diameters. Alright, so it says for each arc, determine its measure and determine what type of arc it is. I look. Well, these three, I don't even have to look here on the diagram. I know that the first three all have to be minor arcs, because there's only two letters. They have to be minor. There's no way around it. Alright? These next three, I'd have to look. CEB, arc CEB, that's more than half the circle, so it's a major. Measure of arc AEB. AEB, segment AB is a diameter, that's half the circle, so this is a semi. Arc EAB. EAB, more than half the circle, it's a major. And arc CAD, CAD, segment CD is a diameter, it's half of a circle, it's a semicircle. Now, if I know it's a semicircle, automatically I don't have to do any other calculations. This is 180 degrees, this is 180 degrees, because both of those were semicircles. Now, if I was looking at this problem, I'd probably try and fill in as much as I could. Well, if segment CD is a semicircle, the whole thing's 180. So 91 plus what equals 180? Or 180 minus 91 is what this is here. So 89 degrees is my response there. These are vertical angles, so this is a 91 degree right there. These are vertical angles, so 98 minus 35 has to be this one, because the full thing has to be 98. So 3, 6, so this is 63 degrees. My bad. 98, 89. That was horrible. 4 and 5, so 54. So now that I have all those in, let's find the actual measures. Measure of arc AD. Arc AD, 91. Measure of arc EB. E to B, well, that's 54. This is 91. So 54 plus 91, carry the 1. I'm thinking 145 degrees. Yep, it's still a minor arc. It might be greater than 90 degrees, but it's a minor arc. How about arc BC? Well, that has a measure of 91 because the central angle is 91 degrees. Major arc CEB, what is its measure? CEB, well, it's everything but the 91. I could add all four of these together, or I could take 360 minus 91. And for me, 360 minus 91 is honestly a little bit easier. I believe it ends up being 269 degrees. You could add all four of those together and make sure it's 269. And last but not least, measure of arc EAB. Well, AB was a semicircle, So this is 180 plus 35. That has to be 215 degrees. And there we go. That's this problem. Naming the arcs, whether they're major or minor, and finding their degrees. Honestly, not too bad. Alright, at this point we're going to move on to an idea that we use repeatedly here. In this one here, I said if I wanted to find the measure of arc AC, I could honestly take the measure of arc AE and add it to measure of arc AC. It's kind of one of those things that you might say, makes sense. Two smaller arcs add to be a bigger one. But we have to be official about it with math. There's nothing that would allow me to naturally do that. It makes sense up here to do it, but there's nothing that would allow me to do it. I have to make a rule that would allow me to do it. It's a postulate. It has no other support than I'm saying this is something we can do. Why? Because we can. So I can add two smaller arcs to be a larger one because of the arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So in the picture here, if I want to find the measure of arc ABC, so from A to C here and going through B, if I wanted to find that measure, I could first find the measure of arc AB, 80, and add to measure of arc BC, 100, and then the measure of arc ABC would be 80 plus 100. That's all it's saying. It's not overly horrible. So here's the question. If I tell you that the measure of arc AB is 79 degrees, and the measure of arc BC is 115 degrees, what is the measure of arc ABC? Well, let's think about this. If I have measure of arc AB, and I add that to measure of arc BC, would that equal the measure of arc ABC? Well, it's from A to C through point B. And no matter how I try to draw my circle here, if I draw my circle, A, B, C, well, that would have to be adjacent arcs because they have the middle point B. So yeah, I think this is legitimate. So what's the measure of the arc? Well, measure of arc AB is 79 degrees. Measure of arc BC is 115 degrees. And that would equal measure of arc ABC. So just add these two together is what I'm trying to tell you to do. 194 is what measure of arc ABC equals. Yeah, pretty simple. Two adjacent arcs have to add up to be a larger. That means if they share an endpoint, and I'm adding it to something that goes through that point with the same endpoints, it's going to be arc addition postulate. Now I could use it in a different scenario. Maybe there's a graph here, and I know the measures of each of those angles. First quarter, second quarter, third quarter, fourth quarter, number of missing assignments. This is entirely fictional data. Now, it says find the measure of these arcs. Well, this is really just like the problem we did previously. However, we're going to be focusing on the arc addition postulate. So if I look here, the first one says find the measure of arc ABC. The measure of arc ABC is, first of all, from A to C through B. So it has to be on the side. Well, it's from the measure of arc AB, 144 degrees, plus the measure of arc BC, 36 degrees. 144 plus 36, I believe, is 180. So number one here, measure of arc ABC equals 180. Number two, what's the measure of arc ABD? ABD, so it's this big arc right here. Well, it's all three of the little arcs, measure of arc AB, plus measure of arc BC, plus measure of arc CD. I can add all three of those together to get my measure of my angle. Well, 144 plus 36 is 180 again. And 180 plus 108, well, that's 288. So number two here is 288 degrees. 180 degrees for number one, 288 degrees for number two. Number three, number four, and number five, try quickly on your own. if you did them correctly, for number 3 you should have got 252 degrees. For number 4 you should have got 216, and number 5 you should have got 180 degrees. So number 3, 252 degrees. Number 4, 216 degrees. Number 5, 180 degrees. If you have questions on those, please see me. Alright, we've moved away from the arc addition postulate. And now we're going to look at what it means for a circle or an arc to be congruent. Congruent. Same size, same shape. Well, for something to be the same size and shape here, well, the only distinguishing characteristic of a circle is that it's the same distance from its center. So it would make sense for me to say circles are congruent only if they have the same radius. If they have the same radius, they're the same size. And they're the same shape. A circle is a circle. It's either going to be similar or it's going to be congruent. If it's congruent, it's the same size, which means it has the same radius, or the same diameter. Now, arcs are only congruent if they have the same size, which means the same measure, but also that they're either of the same circle or the same size circles. I could have two arcs that have the same measure, but are clearly different size. Well, what do you mean by that? Well, if I look at something like this right here is two circles on top of each other. If I drew a segment here and a segment here called the radius, this arc here and this arc here would have the same measure because they have the same central angle. But one is clearly bigger. One is significantly bigger than my marker. One is the size of my marker, not the same size. So it has to be the same measure, same central angle, and it has to be of same size circles, meaning either the same circle or congruent circles. So same measure, same size circles. So in example 4, I'm asking you to determine whether the red arcs are congruent or not. Well, if the arcs are congruent, they either have to be of the same circle or congruent circles. The pair on the left are not of the same circle. So the first thing I'm going to check is just to see if those two circles are the same size, which means the the radii have to be the same size. Well, segment here and the segment here is both from the center to the edge of the circle, and they have the marking saying they are congruent. So these two circles have the same radius, which means these two circles are the same size, which means these two circles are congruent. Now all I need is, do the arcs have the same measure? Arc AB has a measure of 145. Arc CD has a measure of 145. Measures the same, circles are the same size. Those two arcs are congruent because they have the same measure and are the same size, circles. Over here, right away, well, if these are two different circles, again, so it has to be the same size circles, first of all, or the same circle. It's not the same circle, so I'm going to look right away. Same size circle, 4 for one radius, 5 for the other radius. No, those circles are different sizes. One's bigger than the other. There's no way the arcs can be congruent because the circles aren't congruent. How could their arcs be congruent? No, not going to happen. Now, both of the arcs have the same measure, but again, they're not of same size circles, so the arcs will be different sizes, like back here. Well, that's all I have for you today for this section. So this section dealt with a few different things. Basically, what an arc is, part of a circle, and how we find its measure, the central angle, and how we can add the angles together, and what it means to be the same size arc. That's really what the section is about, is we're looking at just the arc. So the first section was all about the tangent. The second section is all about the arc. And that's all I have for you today. Till next time.